We have a function f of x equals x plus 6 over x minus 3. How do we construct the graph? So x equals 0, x equals negative 6. Negative 6, that's going to be 0. We have one flash of hope that x equals 3. 1. X equals 3. Y-intercept occurs when x equals 0. That's the point f of 0. 0 plus 6. 0 minus 3, which is negative 2. As x approaches infinity, f of x approaches 1. As x approaches negative infinity, f of x approaches 1. So we have the horizontal asymptote. So we've got to go through this point and this point. Got to be asymptotic to this line. And then again, we're asymptotic to this line. And we're going to approach y equals 1 here. Meaning that the graph has to do something much like this. Start over here, down through here, and do this. And then it's got to start up on the right side of the x equals 3, because if it starts down below, way down here, it's going to have to go through the x-axis. It can't go through the x-axis unless f of x is 0. And f of x is 0 only when x equals negative 6. If no other value of x gives you the numerator of 0. So the graph, I'm going to label this. Label the x-intercept, the y-intercept. You want to label the vertical asymptote. You want to label the horizontal intercept. Okay? That's what you're going to have to say with this. And if you've done all that, I mean, those of you who've done the homework, and I think everybody in here is working on homework, and most of you who completed most of it, probably 80% of that. Okay? If you've done that, then I would expect you would understand what I just told you here. If you took good notes or looked at the videos class last time, you would already have known how to do this. The open math videos show you how to do it. And it's well explained for the most part. So think about what it takes to get yourself prepared to construct a complete solution. Okay? Again, you have all the bits and pieces from homework, but most of you didn't put them together. Wasn't, totally terrible. You need to figure out how to use what you learned in open math to solve problems. And again, you might be too reliant on the videos. You might not be finding them out. Obviously, work. Looks pretty good. At least hold up. Okay. Now, we have P of X is X minus 8 on X plus 12. And this. Now, I want you to expand it using distributive law, but I've done that so many times that I'm not going to do it anymore. Okay? But I want you to write out the distributive law when you do this. Anyhow, you get x squared plus 4x minus 96. So expanding, we get 2x equals this. Okay. Now divide by x plus a. Let's say x plus 5. What we do, we get x plus 5 into x squared plus 4x minus 96. We need an x here because x times x squared, x times x gives us x squared. And then when we subtract, we're going to get negative x minus 96. I don't know why I picked 96, but I did. Okay, then x goes into negative x. Well, what do we need here to multiply x to get negative x? That's minus 1. We get minus x minus 5. And now we change the signs here. We get negative 91. So this is then plus minus 91 over x plus 5. Okay. Now, using transformations, we want to graph C over x plus a, where C is the number we have. So here's our rational function. And here's my linear function. So we want to construct a graph of the rational function. You have the basic function 1 over x. Then we're going to have a graph like this. I haven't labeled the points, but since people didn't do particularly well on graphing the basic functions, probably ought to include points and the scale. Okay, so we want to do that, but then Your vertical stretch by a factor of 91. Well, that's going to give you a graph that's much higher than this one, and much lower. Now, this is only maybe vertical stretch or vertical stretch at 91 would be much higher than this. Then, let me color it short, so excuse me. No, I And then you cut through the x-axis, which may come down like this. Up like this. Then -5 units in the x direction. So now y-axis would be moved up to s equals -5. And the graph would look something like this. I haven't constructed those carefully for this process. Been through a number of times. Don't understand it, you need to review transformations because it's a big deal and it's not going to go away. Okay. Anyhow, now I'm going to do the graph of x minus 1. Y equals x minus 1. Has a slope of 1, y-intercept of -1. So here is y equals x minus 1. Minus 1, y-axis equals 1 from the x-axis. Then you're going to add this function. This function does this sort of thing. And this sort of thing. You know how you put these two together into a graph? Well, this one's going to approach 0 here. So your final function, as soon as this gets close to 0, your final function will be, this gets a little bit negative here. We add that to what we have here, and we're just below this line. Approach this line as an asymptote. But then things are going to go south and it's going to start curving away, approaching this asymptote. Over here, a little less clear what would happen, but it's worth thinking about. Okay, so what I would want to say, if you just draw the graph of x minus 8 times x plus 12 over x plus 5. In the same way we drew this graph, we find it goes through the x-axis of 12 and negative 8. The y-intercept would be negative 8 times 12, which is 96, divided by 5, which is 19 and a fifth, so that's about 19. Points. Intercept what x equals negative 5. Intercept here. Now, one more time last program. So then you reconcile all that with this picture. Then when I drew this, I just drew it all that carefully with the scale. This curve would be somewhat lower. Look up through the x-axis. Well, that's the process I want you to follow. I want you to follow. What we learned from that. But basically, if you graph the function here with your asymptotes and so forth, figured out your slant asymptote with the x minus 1 function. Then pretty good. I'd really like to see a good attempt at using transformation on this function. But main thing is the overall picture of the graph.